This will be about the sine law and how to use it and how to apply it. So we'll just take a look at this first scenario. The triangle that is labeled ABC has an angle of 80 degrees at corner or vertex A and another angle of 55 degrees at corner B. And then we're given a side length of 12 meters at A. And little a will be directly across from the capital A. So this angle, or the side length, sorry, will be across from the angle of 80 degrees. So the first thing we're going to want to do when we're trying to find out side length B, because that's what the question was asking for, is get a nice picture in front of us. So let's draw a picture. Once you've done that, we'll just take a look at what we have. So right now, what we're dealing with is the given angle of 80 degrees. That's what we were given here. And then angle B was 55. That's over here. So these two are given. We are given the side length opposite angle A of 12 meters. Okay, and then we are asked to find measure B. So how long is that side length of B? So this is what we're looking for. Okay, so let's go to the sine law. So the sine law is three ratios equal to each other. And we only need to choose two of them to make this work. So we're going to look for one item, in this case, side length B. So we need to know three things to find the fourth. So looking at the letters that are given here, we have letters that coincide with the letters in the equations. We don't need to really worry about what the letters are. It could be X, Y, Z, but it's all about positioning in this case. So we'll stay consistent with where the measurements and the angles are. So to find side length B, we're going to use B, obviously, and we're going to use A, because A has two measures that we know, the angle and side length. So we're going to focus on this part right here. Okay, so we're going to go A over sine A equals B over sine B. So let's start with that. A over sine A equals B over sine B. Then from there, we're going to sub what we know. A is 12 over sine A, which is 80 degrees. B we don't know. Trying to find that. Over sine B, which is 55 degrees. Okay, then from there, we're going to isolate for what we need, in this case B. And you can do that using the cross multiplication shortcut or algebra. Either way you do it, you're going to be left with B equals 12 times sine of 55 over sine of 80. Okay, so this is a side length that we're looking for. So we don't need to worry about hitting the second function button on the calculator. So we're going to go and just make sure our mode is okay. We're already in degree mode, which is perfect. If we have to find the angle, then we get the right number. If you were in radian mode, say for example, radians was highlighted, then you'd need to move your cursor down, highlight the degrees, and hit enter. But for this question, that's not necessary. Let's move to 12 times sine of 55. Divide by sine of 80. Equals a number that has 9.98. We're going to round that. The question was asking to the nearest tenth. So tenth is here. That means the 8 is going to round that 9 up. And that 9 rounds up, which means the 9 in front of it will also round up. So we're going to be left with 10.0. It said nearest tenth. So we're going to show that this is 10.0 meters. So we have figured out side length B, because that was our goal. Moving on to the next scenario. In this case, we're looking for an angle, so angle B, and we're going to round to the nearest degree. So we're looking for that measure there. Okay, angle B. I know angle C and side length little c. I know side length B, but I don't know angle B. So the two ratios we're going to use will be B and C. So we're going to use this part. Okay, so we'll start by going B over sine B. Remember the B is a little b, it's a lowercase b. Okay, as we're just correcting this here, lowercase letters are used for the side lengths of the triangle. Uppercase for the angles. Sub in what we know. Side length B is 9 over what we don't know, sine B. B is the angle we're looking for. C, side length, is 12. C angle is 80, so sine of 80. Again, we're going to do that similar step that we saw previous, where we isolate for our variable or our unknown. In this case, the unknown is the sine B. So sine B is equal to 9 times sine of 80 divided by 12. So we just show that as 9 times sine 80 all over 12. Okay, now when we go to the calculator, we're going to do this all in one step, and to show what we're actually doing, to find the angle, we're going to go sine minus 1. So second function sine, and then you're going to put all this in. Oops, I don't need the equal sign yet. So go sine minus 1 in brackets 9 times sine 80 all over 12 equals. So go back to the calculator and we'll just double check that we are in the right mode. So I had changed that previous, so it's in degree mode, which is good. And now we're going to go second function, sine. See that minus 1 there. And now we'll go and put everything in brackets there. So 9 times sine of 80. And then all that divided by 12. And then we get 47.6 in this case. Just write that here. 47.6 degrees. And we had said we want to round this to the nearest degree, so 48 degrees. All right, let's move on to some application. So this scenario here, we'll just read through it to kind of get a visual for ourselves. Two chains are attached to hooks 2.8 meters apart on a ceiling and a winch to lift engines. The chains are 1.9 meters and 2.2 meters in length and make an angle of 86 degrees with the winch. A worker determined that the angles between the chains and ceiling were 40 degrees and 54 degrees. Was the worker correct with his angles? So these are the angles that we're going to check, but we need to make sure we have a visual to work with. So go ahead and draw yourself a picture so we can see what this looks like. Here's one here. Okay, now that we have a picture to work with, we're just going to keep in mind our equation, and I'll just go borrow this graphic. So we want to use that. Okay, so when we look at what we're actually trying to figure out, we are trying to solve and show for that angle and this angle. Okay, so we're trying to determine if the worker was correct by telling us that that angle is 40 degrees and that's 54 degrees based on the measurements that were given. Okay, so because this is a ratio, equal to another ratio equal to another ratio. All of these side lengths and angles within that triangle should be proportional. And because they are, we can go through and check the 40 and 54 degrees. So let's start with the 40 degrees. Okay, so I'll just get that out of there for 1 sec. So to work with the 40 degrees, we're going to be checking sine A, that angle A. So we have angle A, which we're going to find, again, just to make sure, and side length A. So right here is the first proportion, the ratio of that proportion. The only one that we actually know is C. We know the angle, and we know the side length. So the ratio that we know is for C. So we're going to be working with sine A and sine C. So let's write down what we know. A over sine A equals C over sine C. Sub our numbers in. A is 2.2. We're looking for sine A, so leave it as is. C is 2.8 over sine C, which is 86. Sine of 86. Okay, so from there, what we're going to have is sine A. I'll have to do that up here. Sine A equals 2.2 times sine of 86 divided by 2.8. 2.2 times sine of 86 all divided by 2.8. And again, because it's an angle that we're looking for, you go sine, second function of 1, and put all this in brackets. Okay, it's getting a little bit bunched there. So 2.2 times sine of 86 all over 2.8. And let's figure out what that is. Clear out the one from the question before. So again, it is an angle, so we're going to go second function sine, and we'll go and put everything in. So 2.2 times sine of 86. And we've already put this into degree mode, so everything's good to go. And then we're going to divide by 2.8. So we get 51, and then some decimals after that. So we'll just write that down here, 51.6. So leave that there. So far we can see that sine A is 51.6, or we just go A equals 51.6. So we know right away that the worker's angle for A was incorrect, whether it's a whole number of 52 or 51.6. Okay, so let's move on to the next one. So we're going to move to angle 54 and just check that. Let's pick a different color for that one. Okay, so our goal now is to check 54. And we are again going to use C because it's got a full ratio. It's got the angle and the side length. So stick with that one. And we're going to check B. So we're going to use B this time. Okay, so we'll go B over sine B is C over sine C. Okay. And then we'll just sub in what we know. So B is 1.9. We're looking for sine B. So we leave that as is. C is still 2.8. and sine C is still 86. So we'll solve for sine B. Okay, so I'll just go ahead and put the second function right away this time just to save some space. So we have 1.9 times sine of 86 all over 2.8. And this will give us an angle for B. Okay. So again, just go to the calculator, work with our numbers. So we're going to go second function sine, okay, and then 1.9 times sine of 86, all divided by 2.8. We get to 42.6. Okay, so let's put that down here. Degrees. Okay, so let's just check one thing. Well, it doesn't ask for rounding, so it is enough just to take a look at it and go, okay, yeah, they're definitely off. So his angles that he gave us were definitely wrong. This could have been rounded to 43 and this to 52, or just leave it as is. But for now, we just noticed that our answer to this question is the worker was not correct. His angles were off. Angle A was 51.6, not 40. And angle B was 42.6, not 54. So we can see that his numbers weren't right.